How'd you like to listen to .NET Rocks with no ads? Easy. Become a patron. For just $5 a month, you get access to a private RSS feed where all the shows have no ads. $20 a month will get you that and a special .NET Rocks patron mug. Sign up now at patreon.netrocks.com. Welcome back to .NET Rocks. I'm Carl Franklin.
And I'm Richard Campbell.
And we are in our respective places on opposite sides of the North American continent.
Absolutely.
As we usually are. But I don't know, you caught us in the middle of 3 or 4 conferences here, listener.
Yeah. Well, in the last few shows, again, time shifting being hilarious, were all shows we did in Porto. And some awesome conversations, really neat folks we never talked to before. I always tend to, when we're going to do in-person shows, I try to go after guests we've never had on before.
Right.
Yeah.
New stuff. All good.
I would point out, I am, it's getting towards the end of the year, so you know what I'm working on.
The end of the year geek out.
Yeah. Yeah. I know it's close to the end of the year when I have to open up my script files and start pulling stuff forward for space and for energy. And
I can't wait. There's been so much.
There's so much good stuff. They're both going to be, I'm just committing now. They're going to be long. I
mean, you could just do a whole one on the JWT, right?
Oh, the JWST and the crisis in cosmology. The current proposal, they're now floating around. Maybe we're wrong about the age of the universe. Maybe it's twice as long as we thought. It's 26 billion years instead of 13 billion.
Wow.
Which just is stunning. I mean, I love the fact that this is why that instrument went up there, right? It was to test all of the assumptions we've been making, and it has delivered. Do you remember when we talked to Amber Strong about that? This was one of the science, and she's just like, okay, there are things we're finding that cannot be there. There's something we don't know.
Yeah.
And it's a big something.
And Vishwas is looking at us like, did I just parachute in here from another planet? Am I on the right show?
Anyway, don't get me started. Oh, wait, you did.
I did. I'm sorry.
You're late now.
I can't wait. So, well, let's get started with Better Know Framework.
Awesome. All right, man. What do you got?
Well, I've talked about this show I've done with Brian McKay, the AI Bot Show, before.
Yeah, we had him on.
Yes. Yep. And we have just started getting into code and using C# with the API to do, chaining, get the results of one prompt, chain it into another. But we attempted to do one last week, and by last week, I mean,
a few weeks ago.
I think it was the 25th of October we recorded with a guest, and for some reason, Riverside FM, which is what we record with, decided to completely trash or not finish uploading the screen share. On top of that, so we're going to record it again. That's the thing. So it'll be episode 11. Watch for that because it's going to be amazing. We're basically trying to push GPT-4V image recognition to its limits.
Oh, wow.
That's what we're trying to do. But in the course of doing that, Brian actually got some results, and we're going to re-record it. So I don't know what's going to happen the second time. The first time, first time he got results that he didn't expect, and he tried these same prompts with the same images and got completely different responses.
Yeah.
And it turned out either somebody's watching or it's just learning. No, that wasn't a good response. There might be something else looking at the responses and tuning the algorithm in a matter of 24 hours.
Well, there's also another possibility, which is that generative AI models have a variability that allow for a range of answers.
Yeah. And I kind of got into it with him and his guest as well. The whole idea of, do these large language models reason? And my stance right now is no, they don't. And when presented with the facts, this is what they do. They take this. How is that not reasoning? My position is, Well, because it gives you inconsistent answers.
Well, more importantly, it's just a statistical model.
Right.
Like there's no reason to be had. It's not weighing any factors at all. It just gives a statistical result.
Right. And, but if you want to just look at it empirically, when you ask somebody what's 1 + 1, and on Tuesday they say 2, and on Thursday they say 9.
Well, you ask the same question over and over again, it'll give you different answers.
Yeah, that's it. Yeah. And so therefore you can't count on it. It's not reliable, and it's not what you think it is.
You don't ask a stochastic parrot for facts. That's not what it's meant for.
I'm sure Vishwas has lots of things to say on this, but anyway, tune into the AIBotShow.com. Starting at about episode 9, I think, is when we started using code, but in episode 11 is where we start really pushing the boundaries with GPT-4V.
Love it.
Know it, learn it, love it.
Cool, man.
Who's talking to us today, Richard?
Grabbed a comment off of show 1829, the one we did just earlier this year with our friend Vishwas, when we were talking about fusion development, which apparently is a term that's now fallen out of favor. But this is about the idea that the Power Platform presents an awesome way to build heterogeneous clients against cloud backends, and that there's a role for traditional .NET developers in there and building some of those backend services and even building client-side components. And that was the idea of Fusion, that we can all work together. I don't know how well it's caught on with folks, but not that hip. But we did get a comment off that show from Jim, who I believe is a regular. He said, every time I hear someone talk about how easy it is to build with Power Apps for a power user, I shake my head and I have to think to myself that we've lost something in the past 20 years. I went from IT support dude with no real software development training to a software development leader, in large part because of Visual Basic for applications, which made it easy to learn to program. We didn't need a solution that put hard to maintain Excel formulas into a web app. We had a problem that needed to get solved and get back quickly to developing more apps. We need tools that get us to the equivalent of the late 90s and early 2000 desktop development experience, not things that try and mimic Access. That means one click to create a project that I can start dropping UI elements into and then writing clean code with a minimum of ceremony, not hiding logic behind inside of text boxes. And I'm going to turn off my rant before it turns into a blog post. Now, Jim, I would say you're misremembering some stuff too. Like, first thing that I came to appreciate, I said this the other day on another show where I said, I think WinForms is the exception. It's the only product that ever had a great designer. Every other attempt to make a great designer, I'm going to look at you, Front Page or Dreamweaver, much less WPF. Every other attempt to make a great designer has fallen on hard times. Only WinForms had a great designer.
There is a reason for that. The reason is WinForms is a pixel-based grid, and all of these other things are dynamic and don't use, And that's why you can't have a visual designer when you're not pixel based.
Well, and the downside to the pixel based is then you go to high res monitors and oops, or you want to work at mobile, oops,
or you want to scale.
All of those problems are introduced, and so that's why we have this one draggy droppy designer that people fell in love with back in the day. But the idea that VB ever built clean code of any kind and with minimum ceremony, like it was good at getting stuff done, but boy, you had to practice carefully to make maintainable projects.
Yes, you did.
It's a bit of a nostalgic effect to think, things were so much simpler then. Well, they were, because we had VGA displays, one type of machine to deal with. And, it more or less worked that you were writing code on the same kind of computer you were going to run it on. Like life was simpler in that respect.
I had a flashback to the 90s when I had my little kids and, we used to play DVD games, right? On the computers of the day, dug out some of those DVDs, and played them, brought them up, and I was thinking, this is going to be great. We get to do these cartoony, mathy things, right?
Yep.
Yeah, it's like the size of a postage stamp on my screen.
Your screen's just a little bit higher resolution now.
Yeah, and you blow it up and it does not look good.
For the history of .NET, I have all of those great slides of the conferences from 2000, like the original PDs at Tech Ed when .NET was first announced, and like Mix 06 and so forth. I had to get all of those graphics remade because they were like 320 by 280, 800 by 600. Like back then, screens weren't the same resolution, and they looked terrible. Trying to display them on 1080. So I literally sent copies of them to a designer and said, remake these as 1080 for me. So I have the only ones. I have the only good-looking Mix 06 graphic. Like it's me. I made it. It's mine.
That's very cool.
Anyway, Jim, thank you so much for your comment. And a copy of Music Code By, it's on its way to you. And if you'd like a copy of Music Code By, write a comment on the website at .netrocks.com or on the Facebooks. We publish every show there. And if you comment there and I read it on the show, we'll send you a copy of Music Code By.
And, you can follow us on Twitter if you like to, or X, or whatever the hell it is today. It's going to be Z tomorrow, I'm sure. But, yeah, we're still there. But the cool kids are hanging out on Mastodon. From my perspective anyway, I'm at Carl Franklin at Tech Hub Social.
And I'm Rich Campbell at Mastodon.social.
Yeah, send us a toot. Maybe you'll get a copy of Music to Go By.
There you go.
It's another way that you can leave a comment. And that brings us to our good friend Vishwas. Vishwas Lele has been on the show some 13 or 14 times. He is an Azure and AI expert. His bio is long, but I won't belabor that here. He's a real great guy as well. Welcome back, Vishwas.
Thank you.
What you been up to?
What you doing?
What you doing?
Like everybody else, got started with ChatGPT, OpenAI, Azure OpenAI specifically. For Azure developers like me, it was an easy sort of way to get into generative AI. I'd been working on some AI ML stuff previously, but generative AI, of course, has changed everything that we knew before.
Now, you're in Washington, D.C. I think a lot of your customers are government. Like, aren't they pretty careful about adopting new technologies? Like, I'm always impressed that you're in these things so early on.
Yeah. So, yes, Richard, that's true. But I do work with government and commercial customers both. The idea is that can we try out some solutions in the commercial world, bring some of those solutions to the government community. So that's been the pattern. But you'll be surprised. The government customers, Microsoft has Azure OpenAI service that was FedRAMPed, right? So it has available in a certain secure setting. That was an announcement that came a few months ago. So there are civilian agencies who have lots of needs for automation of processes and processing of documents, and they are definitely looking at generative AI models to be able to expedite some of that work.
Well, I know the government is currently sharpening its claws to to put some restrictions on AI. They've been sort of befuddled about this whole thing from the very beginning, and I'm not so sure how well they understand it, but clearly there's some legislation that needs to happen, especially around copyright protection and that kind of stuff, and licensing. But what are your thoughts on that? Have you heard anything being in D.C. about what they plan to do?
Well, like you, there's been news that White House is preparing for a major announcement. I don't know if it's a good thing or a bad thing. You're right. I think we do need some guidance there, but I always worry about what kind of guidance and will it impede the amazing amount of overall. I mean, there are negatives and there are positives, like everything else. I do think that this is just an amazing development that we will look back 5 years from now and say, oh, something new started in 2023. So I'm hoping that the legislation that they're coming up with, I'm hoping with the industry leaders, is a responsible step, but does not curtail the progress and the amazing possibilities that we see from this technology.
Yeah, when I think about the logical roles, it's like, it would be good to have some privacy legislation. You've been needing that for ages.
Yeah.
Large language models notwithstanding. But to me, the one area that you want that from a public perspective you care about is source of data. Yeah. Full stop. If you're going to make an LLM available to the public, even for a fee, you have to tell them where you get your data from. That's an easy one. And there's nothing profound there. It's not a secret. Presumably, it certainly starts to tackle the copyright issue, but it's just like, hey, you want to compete, make distinctions between different LLMs, talk about source of data.
Right. So Richard, I think source of data, and there's been a debate about, what do open source models mean, right? Is it just publishing the weights of your model? Does it make it open source? Or does announcing to the world what sources that your models were trained on?
Yeah.
Is that the definition of open source? So you're absolutely right. These companies have to, at some point, tell us what are the source of data? But that's different from citations. Once the response is being generated at a sentence level, that's very hard problem to cite.
Well, and that's what you really need, right? I mean, nobody wants a 50 terabyte list of sources, general sources that it's been trained on. But what I want to know is when it tells me something, where did you get that fact? But as you said, it's very hard because it's a statistic model that predicts the next word that's going to come. How does it know?
And arguably, it's not pulling from any one source. It's not pulling of the data that it processed against.
Right.
Yes, that is true. We can sort of break the generative AI technology into two parts. The ability to comprehend what you're saying. So you're throwing it a prompt and it is trying to comprehend and trying to give you an answer. And the second part is the general knowledge that it has captured through the training process, right? If you think of generative AI in two terms, right? And I think we are going to get into this more. I look at it from the perspective of how can generative AI make me a better developer? How can I solve everyday problems that are there in the businesses in IT? How can I solve that? So from my perspective, I try to break like I said, into two parts. The part about comprehending and sort of listening and reasoning, and then part about general knowledge. I tend to leave the general knowledge part out if I can. And when I'm asking for a prompt or asking for a response, I'm going to provide you a context, and you should only reply based on the information that I'm providing you, commonly referred to as the RAG pattern.
Yeah.
And that is very important to me. So, Richard, your question about sources and citations is very important, but in the kinds of solutions that I'm building, I'm providing it a context and saying, I'm going to give you these 10 pages of information and you need to process that. And that way, the hallucination and the accuracy is much higher to begin with because I'm controlling the source.
I agree. And I think that code in general, code generation or help with coding is where AI, this large language model absolutely shines.
Sure.
And nobody's going to complain that, that algorithm was lifted out of my open source project. Well, it probably wasn't. It was probably put together just by statistics, but I've found that's where it really shines. And that's not where people are complaining. People are complaining because it's taking their artwork and appropriating it. Artists, like all the artists are crying about this, right? And this is why people don't trust it. But as anyone who's writing complex documents that are in or code that are in a specific, as you said, context, right? That's where it really, really shines. And before I stop talking here, the other things that I like about it are the new ChatGPT Bing, web interface. So instead of using the data that it's trained on, you can do essentially what is a web search, but it goes out, finds multiple sources, puts things together, and if it finds the answer, it sort of gives you a nice, concise answer instead of having to scrape it out of different sites. And also, if it can't find an answer, it'll say, you know what? I searched all over the web and I couldn't find that thing that you're looking for. Maybe it doesn't exist, and maybe here's some documentation that you can go look at and see if you can figure it out yourself.
Yeah, that integration, because all of these language models have a knowledge cutoff date, December 2021 or some date like that. So if you ask a question that goes beyond that, of course, having this Bing integration where you can go do a web search, you could do that, I guess, with ChatGPT 2 with some plugins. But Bing search sort of gives you that. What I've found is it generally works, but there are situations where the citations are not complete.
Yep.
And that merging of real-time lookup versus what the model has been trained on does not work as seamlessly.
You're right.
As you would expect.
And especially for things like C#, you're better off using the default model that it was trained on to do some code. Write a routine that does X, than you are using the Bing stuff. The other thing I like about it now is I can say, here's a URL to a PDF. digest this and then tell me why, my fridge doesn't work.
That's right.
And it will actually do a good job of diagnosing. And you can take pictures and upload it, and it'll understand what it's looking at in the pictures most of the time. This is what we're finding out anyway.
Carl, that's a very good example. Give it a 50 or 100-page document and let it read it, and then have a conversation with it and say, because, this 50-page document presumably is talking about different problems with the fridge. You don't want to go through that. You can say, okay, now that you've read it, I'm going to tell you 2 symptoms that I'm seeing with the problem that I'm having. And can you narrow it down? And then having a conversation with that's just amazing.
It is amazing.
That's a great way.
And it speaks to the strength of this model. It is a good summarizer to be able to ream through a lot of information. And plus, you can validate. It got it from those 100 pages. So once it gives a statement like you should do this, you can take that phrase and search in that document and probably find exactly the reference you need to say, the document really does say this.
I found I did this once with my amplifier, and it actually gave me the answer. It said on page 53 in this section, here's what it says.
Right.
So it actually told me where in the document the answer lied. And this was a real experiment that I did, and I had a real problem with a piece of gear, and I literally told it to read the PDF of the manual, and it in like 5 seconds gave me the answer.
The challenge that, let's say if you're a 100-page PDF document, either it can read it completely, that's one thing, but, what if you have thousands of 50-page documents?
Yeah.
Then you're trying to sort of come up with an answer, and you're eventually going to run into a limit, even though GPT-4 gives you 32K models, which is about 250 pages or so. What if you had more pages, and then now you can't feed that into the model?
Right.
And now you have to do some sort of a search, a vector search of some sort, get the right content in and pass that as a context for your prompt.
You said the V word, vector databases. I find these baffling, and I'm not so sure that, Joe web user is going to be able to figure them out. Can you briefly explain what they are? And
Sure. And I shouldn't have used the word without explaining it first.
No, of course you should.
Otherwise, how are we going to ask you questions, Vishwas?
Yeah, what's our role here?
No, true, fair. So let's take a step back. So you started out with a great example of having this great 50-page PDF about your amplifier, and you had the model read that completely, and you were able to do that because that 50 pages fit into the size of that that the model supports, which is 32K, right? What if you had thousands of 50-page documents and you're trying to build an answer? You can't feed all of those to the models, at least not now. Maybe GPT-5, GPT-6 would allow us to do that. Who knows? So in the absence of that, what you have to do is you have to go do a search against those 1,000 documents. And the problem is that if you did some keyword search, as we've been used to doing, right? It is not that keyword search is really not conveying the intent of what you're trying to search. You might search for some words and you might get good hits, no question about it. But what if you're trying to just describe the problem? You're just saying, my amplifier works this way in certain conditions, but I'm noticing these problems. I can guarantee you there will be no keyword hits when you write a statement like that.
Oh, yeah.
But you're describing the problem. And what if you were able to take this two lines worth of description and find a paragraph of text that closely resembles this text? And that's what a vector database is. What we are trying to do is we are trying to take every piece of text in that large corpus of documents, and we are assigning some statistical values to it so that we can place certain sentences in a certain manner. So think of every word having a certain number of attributes, and then words that are closely aligned will have similar number of attributes, things like that, right? So now you take that sentence of your description of the problem, you create an embedding out of it, and you can use any of the models to create an embedding, which is you're getting a mathematical representation of those two sentences. And then you are, and this going back to high school math, you're doing a cosine search of this mathematical representation against the mathematical representation of the entire corpus.
Yeah.
Maybe you get 2 or 3 hits, which generally talk about this problem. And then you bring that text back and only send that text to the model, because now you've compressed that information. So that's, if you're able to do that, then you can get answers to the question, even if you have 1,000 documents. And I'll talk about later on the product or application that I'm working on, which basically uses the pattern that I just talked about.
I mean, we don't have enough time for you to explain this, but in general, how does one go about creating a vector database from a tome of documents?
Right. So, let's just take the simple example of you wrote those 2 lines of description of your problem, right? You can go to any number of embedding models that are available. You can say, hey, please give me a vector representation of these 3 lines of text. And it literally gives you back a vector representation of those 3 lines of text.
Right.
And so because these models have been trained, like I said, you play this prediction game, what comes next. You play this prediction game. And by playing this game millions and billions of times, you have assigned a certain attribute to a certain word in a certain phrase of that sentence. And then by placing these values in a multidimensional space, you can say these words together mean something. These words together mean something. And, we all remember the 2014 Word2Vec paper that Google came out with, 2014. And we were so amazed when it could do simple things like king minus man plus woman equals what? Oh, queen. And we were so happy that, these models have now some semantic understanding of English language, right? That was 2014 when the Word2Vec paper came out. And of course, given the complexity of the models, the transformer model, the availability of GPUs, now we can do so much more. We were embedding words literally. Now we're embedding paragraphs and pages, essentially. So so to your listeners, essentially, you have taken your corpus of text and you've created a mathematical representation that tells a model. The model is not sentient. It does not know what it means. But because of mathematical representation, it can take the problem description and say, there are these 4 paragraphs out of these 1,000 documents that seem to be talking about something similar. And you go and pull those paragraphs, and then you go to your prompt and say, I'm going to give you 4 paragraphs worth of relevant information about my amplifier, and I'm going to give you some symptoms. Your job is to take that symptom and try to come up with a plausible answer for the problem that I'm having. That's essentially what's happening.
I get that with the paragraphs that you generate for the prompt, but how, if I have thousands and thousands of pages of documents, is there literally an app that I can just drag and drop those into and poof, it's a vector database, or is there a lot of manual work on the part of the user?
That's a great question. So Microsoft 365 Copilot is going to come out. The release date is November 1st or something like that, if I read correctly. So let's just use that as an example to answer your question, Carl.
Sure.
So Microsoft 365 Copilot would be, now you have inside Word, PowerPoint, Excel, whatever. You will be able to ask, you can go into Word and say, hey, can you please generate me an invoice based on the last 5 invoices that I sent out? Okay. You'd be able to do something like this. How do you be able to do that? Well, maybe you have thousands of invoices stored on your OneDrive somewhere. And when you start training the semantic index, which is a component of the Microsoft 365 Copilot, what they would do is they would go through your OneDrive, open up every document. And most commonly, this is what people are doing. Open up every document. At the page break, take the one page, or some fixed number of words or tokens.
Sure.
Read that from your document, create an embedding, store it. Take the next page, create an embedding using the AI model that I talked about. It could be any text model, and store it. And that's how Microsoft internally is creating the semantic index. Of course, cognitive search now has vector database built into it, right? Cognitive search used to be text search, now has vector database built into it. So now you've go through this whole process of ingestion, which can take lots of hours.
Yes.
Because you could have thousands of documents, but now you've taken your entire corpus and broken it down into a set of embeddings.
So I take it then this isn't something that Joe programmer would do with a bunch of data. Like you need some sort of powerful tool on the back end to do this for you.
This is something I'm trying to understand your question.
Yeah.
Maybe this is the time to sort of talk about the application I'm building and see if I answer that question, and I'll come back, right?
All right, but hold that thought. We'll do that right after this break for these very important messages. And we're back. It's .NET Rocks. I'm Carl Franklin. That's Richard Campbell.
Hey.
And that's Vishwas Lele. And he was just about to start telling us about this amazing application that he's working on. Please do. Go ahead, sir.
Thank you. So I don't know, amazing, but there's an application that we've been trying to build for the last 6 months that has taken up a lot of my time. So we talked about the Microsoft 365 Copilot. We are building a similar capability, but to help proposal developers, right? So imagine you're getting a 50 or 100 page RFP or RFI or RFQ or something like that. And that's a very time-consuming and expensive process, right? Wouldn't it be nice if you were able to take all your past performances? So you're responding to these kinds of RFPs over years prior. Can you take those documents and create some sort of a vector database and then use that to generate a draft of a future RFP, right? Yeah. So to going back to your question, Carl, as a developer, what we had to do was to write those ingestion routines where we take those past proposal responses that you may have submitted to the government or some agency or a state or local or what have you, and write that ingestion routine where we take that document, split it up. Now, there is a lot of work that is happening which says, should you be breaking the document on the page boundary? Is that enough? Because think about it. If you just break it on a page boundary, and maybe the important idea or concept is transcending that page boundary.
Right. Break it up by topics, right?
Break it up by topics. But then how do you break it up by topics?
Table of contents?
Table of contents. That's a good point. But sometimes, most in our case at least, the PDF documents that are usually make up these responses, the table of contents are not that great, and PDF is not a great parsable format in any case, right? So you have to use, in some cases, language models to be able to even parse them out and to break the document down into some sort of a section in some classification format so that you can use it for embedding. So you store, maybe not do it on page boundaries, maybe do it on some sort of a lexical boundary, but then you also think about what if the table of contents has some sort of an inheritance built into it? Is it important for you to capture that inheritance? Because that might come in handy as you're trying to respond to a question, right? So those are all important things to do. So going back to your question, yes, as a developer, you have to think about where your embedding boundaries lie, because when it comes time to generate content, the more precise context that you can provide to the language model, the better response you're going to get. And the more precise context you can get by thinking deeply about how you're going to break your corpus into the right set of embeddings.
Isn't Microsoft Copilot going to do a lot of this for us? Like, isn't this just a solved problem if you just are all in on them 365 and pay whatever per month they're going to ask for?
That's a great question. And let me tell you the differences. So Microsoft 365 Copilot is going to be a general purpose answering engine, right? So you can ask it and say, hey, please draft me the text for an invoice based on the last 5 invoices, and I'm sure it'll do a great job. We've seen demos of that.
Yeah.
It also has access to the graph, so it knows which people you're collaborating with, and it can take into account that. But if you have a complex writing problem where the questions are not single line questions, right? The RFP questions are sometimes the questions themselves are maybe a page long or half a page long, right? How do you sort of create a prompt? So in case of Microsoft 365, you're essentially writing a prompt. You're saying, hey, generate me an invoice, which is based on the past 5 invoices, right?
So much context in that statement that needs to be known that you have defined.
Right. In our case, the context is enormous, right, Richard? Because if you're trying to respond to a complex question, you have to infuse a lot of attributes into that, right? You have to think about what are the pain points that the buyer is expressing in this description. What are the win themes? How am I the one that they should be selecting and not somebody else? Is the buyer cost conscious? Have we done this work? Like, it's great to say that we are the greatest company who can do agile development, but won't it be nice if we can provide some proof points that we have done this and we have had success? So I've just given you 3 examples. There are many such attributes. So when you are crafting a prompt, you need to take these considerations into account. So in case of M365 Copilot, you are writing the prompt, but in our situation, you're writing a prompt that is far more complex. So we are trying to do some prompt engineering on behalf of the user, where they can tell us at a high level what they want to do with their response. And for us, it is very much about that's why it's a co-pilot. It's not a pilot or an autopilot.
Right.
You're leveraging the experience of experienced proposal writers. The experienced proposal writers who have spent 10, 20, 30 years writing this, they know exactly how you should be responding. We are simply augmenting them and providing the first draft, right? All of the innovativeness, all of our engine will not help you win any proposals. Our engine will help you do sort of the mundane steps quickly, so that you can spend more time adding innovation to your response.
Right.
So, if you have to generate this prompt, we think that average user is not going to be able to generate those levels of prompts. And I'll tell you why. Because as good as GPT is, if you give a certain size prompt, it starts forgetting some instructions that you gave in the middle.
Sure.
Right?
Yeah. So they fall off.
So you have to repeat it. So we have to have sort of layers of prompts that go in. And this is why, the team that I'm working with has data scientists in them. And people ask me sometimes, hey, generative AI is pre-trained. Do I need a data scientist? Well, you need a data scientist if you're crafting this sophisticated prompts on behalf of the user by taking some input from them. So, Richard, in that manner, we think that this is a very specialized example of what we are trying to use the language model. And this is sort of the difference with the M365 Copilot. And there are a few other differences. For us, hallucination is very, very important. Please don't go out and say that you did a 5,000 SharePoint node migration when you have only done 50 or 500.
Right.
That'll be a problem, right? So we do explicitly accuracy verification, and there are many techniques that your listeners may be aware of, that you take the generated response, you try to extract entities from that, and language model.
Right. So any definitive statements in there.
Yes, and language models are great at extracting entities, and then you take those entities and then you do a search against your knowledge repository and say, do I see a 500 node migration ever mentioned here?
Right.
And if it is not, then let's just flag it and let a human proposal writer go check this.
Right.
So we are doing those kinds of things here. If you, I'll just extend this by saying that I don't know if your listeners have seen this study from MIT, where there are many studies out there which said, okay, let's just try to measure the productivity improvements of something like ChatGPT. Right. So what they did was they took 400 people, college degrees, good writers, broke them into two groups, 200 each, gave them a writing assignment, and then people who were evaluating them had no idea whether they were using some tools or not.
Right.
So they gave them one writing assignment where nobody was allowed to use any tools. So they got the baseline. Then they gave them another writing assignment, but this time half the group was only allowed to use ChatGPT. The other group was not allowed to use ChatGPT.
Right.
Okay? And now once again, the evaluators had no idea who was doing what. And if you look at the results, pretty amazing results, right? The group that was using ChatGPT completed their work in 30 or 33% less time. And I can point you to the study, so my numbers may be off. But more importantly, the people who are using ChatGPT scored a 33 or 35% better grades than people who are not using. Okay,
so a third better grade in a third less time.
Third less time. I mean, that's amazing. And then
was it fact checked? Because that's my problem. It might be able to spit out beautiful text, but is it right? Yeah.
Yes, and human evaluators evaluated that, right? It was just like, people testing that. That's always the case, right? And we know that human evaluators make mistakes too, as well.
Sure,
right?
Well, and we don't know exactly what they were trying to write. Like, as soon as you get away from non-factual writing, like just exploratory or fiction-based writing and stuff, this is not the same set of problems.
Right. Right. And what is interesting is that, remember I said that they were all given a task where nobody was allowed to use any external tools. So that was to establish a baseline.
Right.
And what is interesting in this study is that folks who did not have great writing ability, right? Even they benefited from, when they were put in a pool where they could use ChatGPT, they benefited from, their grades went up significantly.
I mean, I would argue they would benefit more.
They would benefit more, right?
Yeah.
But, there's very, very interesting thing about that study that I'd like to bring back to your question, Richard. There's very interesting in the study that there's something called, and I'm going to use a fancy term that I did not know until I read this MIT study, called the human-machine complementarity. Okay.
Interesting term. Okay.
So what they did was they evaluated the grades at two levels. So the team that was using ChatGPT, they took the output of ChatGPT and graded it. And then they took the output where humans did some prompt engineering on top of ChatGPT and generated an output and evaluated that too.
Right.
Okay. And they found that there was not much difference, right? So what is interesting is, so where is this human-machine complementarity coming in, right? So people looked at the ChatGPT output, made few tweaks, and then they submitted it. So tying it back to your question, Richard, my theory is that the reason there was not much different from the ChatGPT and the human-machine output was people were not thinking carefully about the prompts and actually writing detailed prompts.
Right.
And we think that by creating these layers of prompt for them, you can get a benefit on top of. So everybody is going to get that 30% benefit. That's going to be at some point table stakes, right?
Right.
Was it Steve Sinofsky? I was reading a post from him recently. He said every text box is going to be LLM enabled soon.
Oh, God.
Right? And it's going to be, right? You start writing and it will just start giving you some stuff. So
no.
Everybody is going to benefit from 30% or 28% or whatever that is, right? So how do you go beyond that? Well, you go beyond that through sophisticated prompt engineering. So that's been my journey to build this tool, take your past responses. And I have to say this. People ask me this all the time. This is not, what we are building is not cheating as a service, right? I tell people, if you don't have good past responses, if you don't have good architects who can come up with a good solution,
right? If
you don't have creative solutions, then what we produce will be pretty, poor and not something that you want. But if you have good past performances where you've done this SharePoint migration work and you can come up with you have architects who can come up with a solution, then this is going to benefit. So
sure.
Really, from a responsible AI standpoint, it is about taking your knowledge and then generating that quickly, and then accurately checking it that you're not hallucinating and saying you did 5,000 node server migration.
Right.
I love this. Cheating as a service. Chess.
Yeah. But also, the the old ComSci comment of GIGO, right? Of garbage in, garbage out.
Yes.
Like we still have data quality problems. Like this comes down to the quality of the data you load the set with and how well you load it. But it is an automation tool, and all automations suffer from the same problem, which is they're only going to amplify what you tell it to amplify. And if you tell it to amplify your stupidity, it's going to amplify your stupidity.
Mm-hmm.
You're absolutely right, Richard. My sort of in my experience in 6 months working on this project, it's clear that you spend a lot of time doing data wrangling. You talked about garbage in, garbage out. You worry about what data is getting in. So be prepared to do those kinds of things, even though these models are great. But I would say one thing. These models are far more accepting of the mistakes.
Sure.
Right? I was just doing this example recently where, we had to calculate some accuracy of some data. And we went out to 3 or 4 external services to go validate this data. And each of the service returned the data in a different format, right? One returned in a certain JSON structure. Somebody gave us XML back. And previously, I would have to write a lot of data wrangling code to sort of parse out that data, get this, and then compare it sort of get
it into a workable format.
It's, to get them into very much imperative code that I had to write.
Yeah, right. And then immediately throw away. Like you're only going to do it once.
But immediately throw away because it's going to change.
Kind of code.
And in case of language models, you can say, hey, I'm interested in validating this source information that I have. I went out and made a call to 4 external data sources, and they're going to give us some data back. And this data may not be exactly what you want. It might be wrapped in some XML or JSON.
Right.
Please try to make sense of the data. And it actually tries to extract entities, whether it is XML or JSON.
Wow.
And does the comparison for you. So I found that writing that data wrangling code was much quicker than previously.
Interesting.
Was possible. So there are these examples.
So again, and it was able to discriminate a tag from content.
It will not. It will, yeah. So as is the case with the imperative program. So I do feel that as a software developer, as we think about these problems, and Carl, you talked about, being a coding assistant is important. And I tend to use, most of the times, ChatGPT for my coding stuff. Mm-hmm. Because it is, of course, I can use the GitHub Copilot. And GitHub Copilot, the benefit, of course, is that, IDE, you're based in the IDE right there. As you're coding, it is showing. But for me, even more important thing is I go to ChatGPT and say, I'm trying to write this routine. And this is generally my idea about this routine. I can describe it in plain English. It comes back with some code. And maybe I take that code, I paste it in there, and then I'll test it. And maybe it'll give me an error, or maybe the logic is not quite accurate. I can go back and have a conversation that, hey, you gave me some code, but it is not handling this edge condition. Oh, let me handle that edge condition for you. Go modify these 3 lines of code from here, and then bring it back to my IDE and change it. So in this manner, it's an iterative development model. So that is a significant time saver.
I had this exact experience you're talking about. Without going too far into it, Callie, my wife, and I like to do word search puzzles, right? And we were getting it in the paper once a week, and we were like, maybe I ought to go get a book. And the books were like terrible. So I actually wrote a word search using ChatGPT to help me do it. And it wasn't completely iterative. And I probably should publish the conversation that I had to get the code. But it started just by putting them all in a line, and I'm like, can you mix them up? Some backwards, some diagonal, some backwards diagonal. It's like, sure. So we just went through this reiterative thing. And then it actually was great. I mean, first of all, I used a GPT API to search for words around the topic of X, camping, right? And I tried all these other libraries that try to do semantic, matching and searching and stuff, and they just fell flat. But, the GPT API was like, no problem. It just produce these words, and I could tell it maximum word length, minimum word length, how many words to come back with, don't use dashes or apostrophes. Like, it was really, really an easy, and it was just a single sentence of English that I had to perfect in this API as a query. So yeah, I know exactly what you're saying. The iterative process of using ChatGPT in particular, to come up with some solution is really, really powerful.
And the model is able to reflect sometimes and say, hey, I asked you to write a poem, and which let's say I wanted to make sure that does not rhyme. And it gave me an output which is rhyming, and say, hey, this does not make sense. And it'll say, hey, sorry, I apologize. I don't think I met your requirement.
It's very polite when it screws up.
It's polite. But Richard, I do want to go back to, you said it is a stochastic parrot, right? Mm-hmm. I would challenge that a little bit, and I put a video out. I'll send you the link. That is not based on my work. That's based on some great research that was done, something called the Othello GPT. And your listeners may know Othello as a game called Reversi. It's a 8x8 board, right? So somebody did this awesome research, and I have an 8 or 10 minute video that I talk about it. And I specifically want to reference that because, we always think, hey, this is a stochastic parrot. It just comes up with something based on what it has heard. And then you start typing, you start talking, or you give it a response, and it says, oh, these 8 words, the 9th word must be this, and the 10th word must be this. Right. So what the creators of the Othello GPT paper did was they said, okay, let's constrain the problem as any good engineer would do. Rather than having a 50,000 vocabulary of English words and then having billions of parameter models, let's just use the same technology, use the transformer network, but let's constrain the problem down to the game of Othello. So Othello is 8x8 board, and limited number of moves, as you can imagine, right? Let's just take the sequences. Let's just go to the World Championship of Othello website, and let's just download all the game scripts. And now your vocabulary is not 50,000 words. It's just the limited number of moves that you can make in that game.
Yeah.
Mm-hmm. And now train the model, train a language model based on the scripts of Othello game. Okay. And now there's a technique in neural networks that has been around for some time called the probes, where you can go to a certain layer of this neural network and say, what have you learned? What up until now, what is your understanding? And what the creators of this paper did was, so let's say 2 players are playing this game, and then let's say they are halfway through the game, or at whatever level they are. And what they wanted to know was, does the model really develop an emerging representation of the board? It's not just predicting the next move, right? And to prove that point, what they did was, what if I'm going to suddenly change the board positioning? I can move these moves around, or the pieces around, and does it now change the prediction based on that? So 2 things I said: apply a probe, figure out the emerging representation of that Othello game. So now it is predicting based on that. Now go in and manually change the position of these pieces, and now see if it predicts something accurately. So what this paper tries to do is try to say that, it's not just a stochastic prediction. In training this over and over and over again, it has developed an emerging representation of the world. And can we just try and apply this to ChatGPT? In some ways, it is developing an emerging representation of the world. Now, there are people who absolutely disagree, Jan LeCun being one of them. But there are data scientists who think that these models are learning something more than we are giving them credit for. So that's a debate, but I'll point to that Othello GPT if you want to read the paper.
I found the link, and I'll include it in the show notes.
Yes.
On your post. And yeah, I'm following firmly in the Jan LeCun space of there are no emergent properties here except the ones that we project upon them. It's software. But you can't argue with its ability to summarize. And so isn't this a kind of summarization? Right? And a good summary also represents an emerging understanding.
Right. But keep in mind, the model has no notion that you're playing a game. It has no notion of who's winning, who's losing, right?
Or that any of those things are important, right? And therein lies part of the problem. Like, this is such the opposite of common sense that you could possibly imagine.
Right. But at the same time, the 8x8 board is complex enough that it cannot memorize the moves.
You can't keep it in your head. Absolutely.
You cannot keep it in your head. So there is some emerging representation, the rules of the game. Mm-hmm. Some strategy is emerging that, anybody who's played Othello knows that, you want to take the corner positions quickly to block your opponent. It is developing those emerging strategies. Nobody said you should do this. So there's something to be said. I found that paper so fascinating that I had to read for your listeners. I had to read it 5 times to understand that paper. These papers are complex to read. And then I tried to synthesize the meaning as I understood it in a 10 or 15 minute video. Looks like you found a link to that.
Yeah, it's 20 minutes, but okay.
No, it's 20 minutes.
It was complicated, so it was a little longer. But I appreciate your thinking on this. And it's great to see you building stuff here, because it does give us all encouragement that there is space for some useful products if you put the proper parameters around it. Like, the caveats are important.
The caveats are important, and think about it in this manner, right? Again, going back to, I'm always looking for how can I build application faster? So think about the 3 applications type that are emerging, right? Of course, the M365 Copilot, you have productivity tools, they are adding LLMs to that. Makes sense, right? Yep. But then maybe you have some sort of a line of business application, a complex claims processing system that most of your listeners can relate to. There's one piece of functionality that we have never been able to, imperatively code. Maybe that functionality we can embed LLMs into your existing line of business application, right? We get some large discounts because if we keep track of all of the invoices and certain product from different vendors, if we can somehow put them together, maybe we can come up with a way and negotiate a contract with somebody, right? Very hard problem to do. We have never been able to add that to our invoice system. Maybe now we can inject LLMs to do that. So that's the other type of application. And then, of course, the third type is a native, problems that we have not been able to solve without generative AI. And now people are coming up with applications, and new applications come out every day.
No, and I appreciate all of that sort of truth that as we narrow in on what these tools are reliable for, it is a new class of automation, and it will take certain workloads off the table that just were bloody hard. Like, I think the easy win is the raising of the average. Like you talked about the writing side, that, LLMs will mean that your ordinary writer is a better writer. One would argue the very best will still be better than any tool, but most of us aren't the very best. But far more interesting will be this true, we couldn't have solved this any other way.
Right.
You were mentioning Othello, and I immediately go to the DeepMind stuff that went after Go. And while that's interesting, DeepMind's also tackling protein folding and is now producing results that we're going to take years to validate because they've tackled such a complicated problem. Like, at this point, they're like, well, it's now come back with some protein fold routines that we've never seen before. And until we prove them, we don't know if they're right or not. And it's actually hard for us to even prove it. That's interesting.
Is the IBM Watson chess program in AI?
Well, it's a decision tree model built in the 90s. Like, it's way more primitive in comparison. But if you look at it predates the deep learning models that we use in generative AI.
But it uses just pure brute force to go through those trees and every possible combination. Yeah.
Well, it has a triage because you can get too deep. But one of the variations on AlphaGo, they actually use the same training model to train against chess. And it slaughtered the best digital chess players out there.
Really?
And it learned in no time at all. Like, it just there was an indication that for this kind of problem space, it was wicked good at it. And
wow.
And also that it, unlike the decision model that was taught against historical games, that AlphaMind model literally was just given the rules and played itself. right? Which is what they ended up with Go. Originally, with the original version of the Go, they trained against classical games and then made a much more efficient version that just trained against itself. So, I mean, there's spaces where these generative AI models make sense, none of which is fact-based, especially when it comes about extracting facts from the internet. You know, that place that really lacks a lot of facts?
Yeah.
So, you know, it's as long as you use a tool appropriately.
Yeah.
And you don't fall into the trap of trusting it as an authority.
Right. Any more than you trust your calculator to be an authority. Calculators aren't as good as the numbers.
Well, at least the calculator comes up with the same answer every time.
Oh,
the inputs are the same.
Don't discount the user error issue with calculators, right? I mean, you have to follow the same sequence of keys, but you get the.
Oh, well. How many times have we run into companies where they base their actions on a spreadsheet that had bad math in it? You know, it's easy to do. The hour flies by with you, Vishwas.
I know.
Every time. Like, I want to keep going, but
I could easily go another hour.
We're going well. Thank you for this. I'm really grateful for the work you've done.
Yeah, me too. And especially, I really appreciate your business-oriented mind of using AI. And that's something that I'm just now starting to, wrap my mind around how a real business is going to use this. I mean, you mentioned the Azure thing, but also Google Bard now can search Drive and Gmail and everything else. Gmail search was always really good, but all these business tools are coming out, and therein lies the opportunity, I think. Yeah. So thanks again, Vishwas. And dear listener, we will talk to you again next time on .NET Rocks.
.NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time. Got transmitter banned by the FCC. Yes, I'm a